Hello, Mr. Holmes with another Zero to Hero video, and on the very big section of work, section 2.6, called data representation. Now, there is a lot to get through here. I'm going to break it down into chunks of about 5 minutes apiece, and hopefully within 20 to 30 minutes we should have covered everything that you need to know for this section. So, what is data representation and why does it matter? Information and data in the real world typically takes the form of analog signals. Analog signals are made up of continuously varying physical quantities such as voltage, sound pressure, and so on. You can see from the graph there that there are no gaps and that the wave is pretty much like a sine wave and it is continuous. In other words, all data and information that we put into the computing system and what comes out for us as people to use is an analog waveform, be it a sound we can hear or the light that is coming from a monitor or a screen. This is what input-output devices do. They turn analog signals into digital signals. And this here is the important point. Everything that happens inside the computer is itself digital. Digital means we're expressing data in a series of digits, namely 1 and 0. So everything inside the computer is digital, and if you look at the waveform, it's square and haphazard, it's not continuous, it's very blocky, it's got discrete parts, it's digitized. Because of the microelectronic nature of computers, they use transistors, which are microscopic little switches. Why is binary used inside to represent information in the computer? It's because digital electronics is built on a microscopic electronic switch known as a transistor. And the transistors can be turned on or off, and on is represented by a 1 and off is represented by a 0. As you can see, it's easier is the wrong answer. So this entire section deals with how on earth do we represent real world data as a sequence or strings of 1s and 0s. And this includes everything from characters to numbers to images and sound. As you will see, the amount of data that is needed to store images and sound can be quite considerably large. So to make this more efficient to transmit sound and images over a network like the internet, we will also look at compression. Compression, unlike encryption, is not designed to hide information, but instead to make the information smaller than the original bit size. So as just discussed, the smallest unit of information we can represent inside a computer is something known as a bit or a binary digit. This is represented by a 1 or a 0. This is not a lot of information, so we tend to group bits together. The smallest grouping of bits that we will ever use is something called a nibble, which consists of 4 bits. Practically, however, even this is too small, and in real terms, the byte or 8 bits is the smallest storable unit of data that you will find in a computer. Now in science you would have been told about the SI units of measurement: K for kilo, M for mega, G for giga, T for tera, and P for peta. Each one of these is a factor of 1,000 bigger than its predecessor. In real terms, a kilobyte is defined as being 2 to the power of 10 or 1024 bytes. That's the actual exact figure. However, for many of the calculations you'll be asked to perform, you do not have access to a calculator, and so you are allowed to use the SI convention. We use 1,000 as the multiplication factor instead of 1024. There's also a very definite relationship between how many states you can represent with a certain number of bits. 2 to the power of however many bits you have. So if you have 4 bits, for example, it could represent 2 to the power of 4, or 2 times 2 times 2 times 2, which is 16 different states. So you need to know the order of the units. So bit is 1 binary digit, a nibble is 4 bits, a byte is 8 bits or 2 nibbles, a kilobyte is 1,000 bytes, a megabyte is 1,000 kilobytes, a gigabyte is 1,000 megabytes, a terabyte is 1,000 gigabytes, and a petabyte is 1,000 terabytes. Finally, I just want to mention that treating a byte as 2 nibbles is a very useful thing to do. There are 2 reasons for this. The first one is that it makes it easier to read. The second is that it has a number of advantages, particularly when we start dealing with converting from binary to hexadecimal and vice versa. Well, that concludes this introduction. Mr. Holmes signing out. Thanks for watching.